I don't think so.
Welcome to Title Adam in the House, the podcast where Florida real estate gets real. Buyers, sellers, builders, and lenders. If you're in the game, then you belong in the house. Let's get you to the closing table fast and with less stress. Let's go. Hey, everybody, it's Title Adam. I'm in the house today with Mike Derengowski. He is a friend of mine. Mike and I held an event in January of 2025 to introduce the community to telescopes. Since then, we've had a lot of fun chatting. And for that, we bring him into the house today. Mike, thanks for joining us.
Hey, thank you. I appreciate you having me here, Adam.
Yeah, thanks for coming in. I'm excited because it's a Saturday. We're here at the studios of Premier Reputation Title in Estero. We also have an office in Bonita. And if you're buying, selling, building, refinancing, or doing a deal in Florida, tag in Title Adam. I'm local and licensed, and I'm ready to help. So here we are today in the studio. Mike, there's a lot of things going on from a space perspective. There's headlines every day about 3i Atlas is coming our way, but there's also a full eclipse this weekend, a lunar eclipse. There's a full moon in Pisces. And so we're here to talk about all of that. But before we get into the big one, which is 3i Atlas, tell me about telescopes in general, because a lot of people may not know this, but there's more than one type of telescope. Let's start with that.
Yeah, absolutely. You have about 3 different kinds of telescopes. Originally, they were invented in 1608 by some unnamed guy. Galileo came around a year later and improved on it and pretty much made the first refractor telescope.
Okay.
Now, a refractor telescope is a telescope like the normal one that people are used to with the long tube, and you look at in the bottom of it.
Right. Spyglass almost.
Yes, pretty much. Yes. You have a lens on the top and you have a lens at the bottom. And that's your refractor. And because it's refracting the light, it's changing the light and pretty much just bending the focal point to the lens at the back. 60 years later, Isaac Newton came around and designed his own telescope. But it was based on a mirror concept that used reflection, and then we call those reflectors.
Okay. So at that point, that might have been even highly controversial that he was changing the game, going from a refraction to a reflection.
Yes.
And that was 60 years approximately after?
Yes, 1668.
Okay.
He invented the first one. And it's actually, the name still sticks with it nowadays. It's called a Newtonian reflector. Dobsonians are a type of Newtonian reflectors.
So are there refraction telescopes still in use today, or did we move to reflection?
No, we use both kinds.
Okay.
Both kinds, yeah.
And would the hobbyists such as you and I have access to both types?
Oh, absolutely, yeah. I mean, both are very common ground. Most beginner telescopes, I would say, would be a refractor, long, skinny telescope. That's, the cheap kinds that you find at, at the box stores and stuff like that.
Yep. Amazon.
And
we're going to
like
put a list, Mike, on our Amazon storefront for those that want to look up at the stars. And we'll put in some different telescope options. I bought some lenses last year for Christmas that I like to recommend to some friends. And so we'll definitely put that in there.
Yeah, High Point Scientific is a good site to go to for your telescope needs. They're very knowledgeable, and they have pretty much everything that you're looking for.
And we'll put that link in there as well. And that was High Point
Scientific.
High Point Scientific. Now, just to go back, now that we talked about the kinds of telescopes, I'll share the story with how I met Mike. And because Mike is a certified instructor with Lee County Parks. He has been sharing his love with telescopes with the community for a long time. And we both live in Lehigh Acres with our children, and our kids go to school out there. I saw an event that he was doing at the park in Lehigh Acres, and I just reached out to him because 2 years prior, I had bought Jade a telescope for her birthday. And I bought it on Facebook Marketplace and from some kid. He didn't know anything about it. He just gave me the books and all the materials, and it was on a mount.
Yeah.
And I brought it home, had no idea what to do with it, put it in the garage, and it just leaned there for 2 years.
Collected dust, probably.
Collected dust, and was, by the grace of God, never fell over and broke. Because we have kids running in and out, basketballs bouncing. And I remember seeing your event and seeing people commenting on what you were doing because you're at Veterans Park. And I reached out to Mike and said, if I threw you $50, would you swing by my house and show me how to use my telescope? And he came over. Mike spent close to an hour by the time it was all set up. And you gave me a crash course that was so good and so easy to really follow, which was to say that, hey, there's two knobs, and there's this one makes it go up and down, this one makes it go side to side, left to right. But you set it up for me.
Yeah, you have to have it at a certain altitude. It's got to be pointed towards the North Star at our latitude, degree of latitude. And here in Southwest Florida, we're at approximately 25 degrees north. So that's what you have to set your mount at.
And I want to say that when you looked at mine for calibration, that it was set proper.
Yes.
But you explained why it was that way. I don't know if the prior owner even used it, to be honest with you, but I remember seeing, okay, so that was something that had to be addressed. And then there's a process of calibrating the scope where you used a distant street light from my backyard and focused in on that, and then used that to kind of get an idea of fine tuning, if you will.
Yes, that was to align your finder scope with your main scope.
Now, my finder scope is actually just a small scope above the tube. What would you call my telescope? You know it better than me.
Yeah, yours is a NexRad. It's a Telerad. It's a laser pointer, pretty much.
Yep.
It's not an actual, scope that you look in and you're going to see something visually.
Right.
It's a laser scope to get you approximately where you want to be at.
Right.
For the most part.
Yep. And which I currently have broken that in transport. So I've been running blind without it. I still have the actual scope on there, but the wire came loose. And so I don't have the laser point. So we went through the process of calibrating that scope. And then I'll never forget what you did for me, which was that you said the scope that you have came with one lens.
Yes.
And that was a good lens. I think that I can't remember the size of it.
There's nothing wrong with it, but
yeah,
you're limited to one magnification.
This is your view.
And that's it.
And you gave me, I believe it was an 8 millimeter.
8 or 6 millimeter.
8 or 6. And that allowed me to look at things in much more detail. And we'll get into this in a minute because it's important. The lens that you use in your telescope is kind of like the zoom level on your phone.
Yes.
Right? And so when you zoom in on something to see a fine detail, you lose the outside edges of the picture. It starts to shrink in. However, without that magnification advantage, you could quickly become bored with your view. And I think that, especially with kids, and depending on the magnification that you're working with, you may not be that far beyond an iPhone's capability.
Yes.
As far as looking at the moon and zooming in and getting that zoom. But that said, you let me have a 6, I believe it was an 8 millimeter lens. And that way I was able to have a different view. From that point, though, Mike, we were pretty much hooked. We were out back every night that the weather would allow. Now, that would have been, I believe, November when I first hooked up with you. And we did an event in January.
Cooler weather, more stable atmosphere.
Perfect to go out from basically sunset all the way through.
Till morning.
All the way till the morning. So I really enjoyed that. And I think that anyone that's looking into telescopes needs to take a couple of minutes and set it up right. Then they need to broaden their viewpoint through different lenses. And further, the set that I bought, and I'll put a link in the show notes, the set that I bought had additional screw-on colored lenses that would go on.
Filters. Yes.
Filters on. And I haven't spent a lot of time with that, but I'll ask you how I can get better mileage on that, because I know that, for example, there's a yellow filter that is just phenomenal for X. And then there's a red filter that they say, if you look at Mars, then it's going to really enhance what you're looking at.
Yes.
But you could have all of the tools, and without knowing what to use when, you could get overwhelmed.
Yes.
And from a cost standpoint, it's not a cheap hobby.
It's not a cheap hobby, and it's a very frustrating hobby at times.
Yeah. How many scopes do you have currently?
Currently, I think I have 11 or 12.
Yeah.
Of all different sizes, makes, and models, and different types.
Yeah. And I've seen when you'll go out to the park to do an event, you will bring a 10-inch Dobsonian. And I'll put some pictures in as we're talking. I'll put some pictures in up here, but a 10-inch, a 12-inch Dobsonian, an 8-inch.
Yeah,
also
I have
10, and 12.
Yeah.
And then you're bringing in
the CSAR. And then once in a while, I even bring in a refractor type, and
and I'll bring mine, which he's helped set up before. And then, we'll take a look at that when we get to the park. So it's a labor of love that you do for the community and for your kids. You've got small children like me. They're running around, they're learning. And I start to wonder now, because your children are about my age of my youngest, and I start to wonder if the iPhone didn't kill the amateur telescope enthusiast because of the zoom levels of these cameras, and how, when I brought my 16-year-old out onto the back patio to look at Jupiter, I remember him saying, that's it. He wasn't really that excited about it.
Yeah.
And I'm like, dude, if you really look, you can see the moon next to Jupiter. You can see 3 of the moons in this shot. And he wasn't really that excited about it. And I wonder if the iPhone and the Samsung cameras maybe killed some of that.
I don't think it's necessarily the iPhone or the smartphones that did it. I think it's a lot of people have an unrealistic expectation of what they're going to be able to see in a telescope, as opposed to the photos that are out there sent out by Hubble and NASA.
James Webb, yeah.
James Webb Telescope,
Yeah.
Space Telescope. Nothing on Earth is going to be able to compete with what you see from that. And those are processed photos,
Yeah.
Stacked photos.
Yeah.
They're hours and hours worth of data.
Infrared images that our eye wouldn't even see without the
Yes.
aid of a computer.
Yes, and they don't have
enhancement.
to. They also don't have to deal with the interference of the Earth's atmosphere like ground-based telescopes do.
Right.
So that puts limitations on what we can see, because even if conditions are perfect, we still have an atmosphere to have to look through, and that causes distortion.
Yep.
So, a lot of times you see these wonderful pictures on online of all these nebulas, these close-ups of the planets, Saturn, and you're not going to be able to see those in most normal amateur telescopes. Some professional telescopes that they have at certain sites and stuff like that, maybe in observatories, yeah. But in most cases you can't. So a lot of people have this expectation that they're going to see all these things, but the galaxies look like little faint blobs. Not to say that they're not cool looking and stuff, because you're still seeing millions of light years away.
Yeah, it's hard to really fathom the distance that scope is covering. And part of that is why I get frustrated. And as an amateur and as a hobbyist, okay, someone who has high school level understanding of physics and science. Now, if we could see Saturn and even see the rings on Saturn from our backyard, and we know that the moon, our moon, is way closer than Saturn. And I just realized the answer because you've told me this before. Why can't we see really granular detail of the moon? Why can we not see that? And it's because the size of the moon versus the size of Saturn.
It's way smaller, for one. And we can see, fairly decent at the moon, but you got to understand that even the small little craters that we're able to image and magnify, on photographs and stuff on the moon, they're still tens of kilometers and miles across. They're not tiny little things. They're still huge things, even
and within that there's details that we don't resolve down to.
Absolutely.
Right.
And there's reasons why we don't have orbiters going around the moon. For one, the moon's gravity is not equal all the way around.
Okay.
So that puts satellites in low orbit around the moon. It puts them in jeopardy of eventually not slingshot, but eventually their orbit degrading and actually crashing into it. The moon doesn't have much of an atmosphere, but it does have a very faint, small one, and it's enough to cause
Just
some
enough.
friction that will degrade the orbit of those low orbit.
Yeah. Wow.
There's a couple of them that aren't there, that there are in stable low orbits. China has one, and NASA has one right now. But that's about the only two that we have around the moon right now. But even those, they can't resolve craters that are only a meter across and stuff like that. You're not going to be able to see something like that from
Now, with a very slight atmosphere. If you could get outside of Earth's atmosphere to get towards the moon, could you then see at a greater level of clarity? Because I'm imagining that it's the atmosphere between us and the moon that's really causing that.
Yes.
Yeah. So it wouldn't even be necessarily a low orbit needed.
No,
But something just outside of the restrictions of our atmosphere. Because I know I've gotten texts from you before where you're like, I've got everything moved out and things have just changed. Conditions have worsened and I can't see anything tonight. It's gone. It's over.
Got foggy in 5 minutes.
And so the Earth's atmosphere presents a lot of those challenges. But I know that for me, looking at the moon, so starting closest to home, looking at the moon for me is probably one of my favorite things to do. And I thought when I met you, I can't wait till the full moon so I can get right out there and look at it, right? And that's like looking right into the headlight of a car.
Yeah,
It's
like a
so
flashlight.
bright.
It's blinding. You see spots for half an hour afterwards. And
now I do have a filter that you can screw on to the lens that will kind of dim that a little bit and allow you to see it. But I feel like, and from what you've shared with me, the best viewing is going to be half or less.
half moon, or even I would say a quarter moon would be the absolute best. And you get better effects that way too. You get more shadows. You get to see more details in the craters, the mountain ranges and stuff like that. And believe it or not, there are certain features on the moon's surface that only pop up when the shadow's hitting it from a certain angle. Yeah, like there's this X, like an X that's in a mountain range, and you can only see this rock formation that's in an X shape. Only when the shadow's hitting it from a certain angle, like on a quarter moon.
Yeah.
And it's for only like 1 day.
And that's it.
And then you can't see it for another month.
Yeah. So the moon is when it's prime time. That's where I like to start every day or every time, and I've seen some really great shots of the moon. I've seen you take some really great shots of the moon with a reflector versus, you've done some great stuff with the Sea-Star as well, which is in its own, it's in its own class, right?
Yeah.
Because of what it does. But sticking with that, a picture that you took and sent to me, it was of, I think the way that you said it was, this is the youngest moon you've ever seen. And it was just the tiniest little sliver.
It's like 1%.
It's the tiniest little sliver of the moon coming through.
Hours old.
Newborn, and it's such a sweet, sweet view. So then we go, going out from there, we see Venus in the sky at night, as true as ever, over to,
or in the morning time, depending on where it is. Right now,
from my backyard.
Yeah, currently it's in the morning time. It rises in the morning time around before sunrise.
And so we're coming into what we hope to be some really great sky viewing weather. Maybe November. Is that about when that's going to kick up?
October, November, the weather starts calming down. It's more stable. Once you start getting the cold fronts and the humidity goes down, because humidity is a killer for telescoping. It fogs up your lenses. It creates a heavier atmosphere to make it harder to see through, and you get less clarity that way.
So think about that, guys, when you're talking about if you're going to get out your equipment at night, look at the weather report. And, anecdotally, when you're in hurricane season, it's going to be tough.
Yes.
Because storms will pop up. But, generally you want clear skies. You want cool weather if you could get it, just to be comfortable.
Cool, dry weather, low humidity. Less wind, because less wind creates less turbulence in the upper atmosphere. Because things even like jet streams, you can have a clear day, but if you got a jet stream going up there, that's going to create some turbulence.
And I got them. They come right over our house to get to the airport. So I know that that's very real. Obviously, you have to set up a place where you have a clear sky. So we've got that. We've got Venus early in the morning right now.
Jupiter's in the morning time.
Jupiter's earlier in the morning.
Yep. Uranus is in the morning, but that's more of you need a telescope to see. It's not more visual.
But Venus, you could do naked eye.
Oh yeah,
everybody's seen Venus in the sky. If you've ever looked up, you can't miss it. And then you start going into, Uranus, you said, with a scope.
With a scope.
And what about Mercury?
Mercury, right now, Mercury's too close to the sun to see, but it was visible about 2 weeks ago, a week and a half, 2 weeks ago. I got a couple days where I was able to see it right in the morning time.
Yeah.
But Mercury is actually harder to see than Neptune or Uranus because it spends so much of its time close to the sun.
So, you can't
it's too close it's too close to the glare. You can't see it.
Yeah. Wow. All right. So my very energetic mother just served us 9 pizzas. So now we've got Saturn. And Saturn is so special. If you won't know this until you look at it through a telescope. It is special. The first time you get to see it, you won't believe it because it's not huge, at least on my telescope, but you can get clarity. You can see the rings. And it almost, to me, is like when I look at you remember when we were kids, they had these reels. It had these little pictures on them, and then you would put them in a Viewmaster. I think
click the little thing. Yeah.
It almost looks like that, almost cartoonish when you see Saturn in the sky because it's so far away, and it's almost like you're looking at an X-ray, through the telescope, black and white. And what a special shot! So, can you see Saturn right now? Saturn is
in the evening times.
Okay,
I would say probably after 11, 12 o'clock. It's going to be up. It's going to be at opposition, which means it's prime viewing time later this month.
Okay. So towards the end of the month, you'll be able to, if you want to see it.
It'll be at its best viewing of the year. Pretty
Good one.
much
Yeah.
September 21st is going to be opposition.
And that opposition will last for how long?
A couple
months?
weeks.
Oh, a couple weeks.
A couple
Okay.
weeks. But I mean, it's not going to say it's not going to be good seeing for it. But
It's just
afterwards,
in the prime.
that's its absolute prime for the
Yeah.
year. It's going to be your best viewing conditions for the planet of the year.
Yeah. Okay. Now, so you have all these planetary bodies. That's great. They're fun, and they're fairly easy with an app on the phone to kind of get an idea of where to look, and then
Yes.
you're dialing in with your different lenses and different magnification. If someone were to ask you, what's that millimeter lens that you just could not do without? What's the the 10 millimeter of?
I was actually just going to say a 10 for my close up for the planets and the moon. I like using my 10. It gives you enough magnification where you can see a lot of details, but it's not so small where it's almost impossible to look through the eyepiece.
Because that's what happens is, again, when you magnify, imagine zooming on your phone, and that's fine. But once you're zoomed in so much, you lose context of where you are. And in a dark sky with light years in between different bodies, you could be just scanning for a long time. So I think that that's important to note, is that you do lose that outside the context of the shot when you go into magnifying. So I usually like to drill down. Just as an amateur, I'll start basically as far out as I can still see it.
The larger the eyepiece, and then you work your way to the more powerful ones.
The moon is a little easier because it's a big shot target in the sky.
Yeah, it's hard to miss.
Yeah, but if you're going for Jupiter and the moons of Jupiter, then that, I feel like you have to start and dial into it. And I love that. I really enjoy telescopes. I like everything about that. Mike, what about when people ask you, like, do you ever see comets on a? Can you see a comet on a telescope?
It's not all the time because they come around periodically, and comets are very fickle. You know, sometimes there'll be a lot of hype on a comet, being like, "Oh, this is going to be the comet of the year, comet of the century," and it either fizzles out or doesn't meet the expectations of what it's supposed to. You know, the brightness and stuff.
Yeah.
But every so often you get some really nice ones. Like earlier this year, we had one that was naked eye visible. Which was amazing. And last year too, we had one that was naked eye visible for a couple of days. And those they only come around like once every 20 years or so.
Yeah.
You know, something like that.
And that you have coordinates so you can kind of get a general idea in the sky where it's going to be.
Yeah.
But I guess more like shooting stars and things like that. Do you find that seeing that through a telescope is often serendipitous, that you just happen to be looking at something in the sky and you see
shooting stars,
a Starlink satellite cross your path or whatever? You're not really tracking an object that fast.
No, they just go right across your field of view. Pretty much. The satellites, they move fairly quick, but you can see them going across your eyepiece and going across your field of view. A meteorite, zoom, it's gone within a split second. Like if you're looking in your eyepiece, you're not going to even really see it.
Yeah. Did I blink? Did something?
Yeah. It goes so fast. So fast.
I remember messaging you the first time I saw a Starlink satellite, and you said, like, that's normal. It'll be there. Wait, and it'll come back around again.
And sometimes there'll be a line of them. You get 6 or 7 in a row.
And that's a lot more common today than it was, back many years ago. But that's something to definitely keep an eye out for. I want to go to Atlas, but not yet, because I know once we get onto that, I'm just going to be completely enthralled. I've read up so much on it, and there's so much I don't know about it and understand physically about it. But before we go there, I want to go back into, because everyone talks about the moon, everyone talks about the planets. Those are great. But where you really shine and what you've shown me that I never knew about before was more in the celestial body. So I'd like to talk to you a little bit about some of those targets in the sky that you could look at as an amateur, as a hobbyist. And I don't use amateur as a negative term, but I don't want people to become overwhelmed with how big space is. Because, Mike, by the time we release this episode, we will have moved into a completely different space through the passage of time. And so when I look at the sky, sometimes I'm so overwhelmed with how much is there to look at. What are some areas in the sky that you could say, point here and look at this? What are some of the ones that people look at? The Big Dipper?
Big Dipper is a big one. Everybody knows about Big Dipper. Orion's especially this coming up this season, this time of year, Orion's going to be coming up. It's going to be visible almost all, it's starting to be visible in the morning times, but it's going to be visible, upcoming all night.
Yeah.
And that's a big thing is it's one of the easiest things to see with a amateur telescope. It's a bright nebula, lots of stars. Betelgeuse is also part of the Orion constellation, so that's a big name. Everybody knows about Betelgeuse.
Yeah.
They're waiting for it to explode.
Yeah.
And, it might have exploded already.
Could have.
We don't even know.
Yeah.
That's a big one. You got lots of open clusters, star clusters that you can see. A lot of globular clusters that you can see. The Hercules cluster, M13 is a popular one that's really easy to see with amateur telescopes. The Ring Nebula is another cool nebula to see. Amateur telescopes, that's really easy to see. And just a lot of star clusters that are all over the place. Open clusters.
Andromeda.
Andromeda's a galaxy that's
You're looking at that though. You're checking into Pleiades. Is that another one that I hear you talk about a lot?
Yep. Yeah, that's a nice big star cluster. That's also called the Seven Sisters after the 7 main stars in the cluster.
Yeah.
Yeah. Andromeda's pretty cool though. That's 2.5 million light years away. It's our closest galactic neighbor.
So think about that. That's our closest neighbor, and a light year is how many miles? I know you've done this calculation for me before. It's exhaustive.
It is, okay.
It's so many miles that they had to come up with the term light year versus say the number.
Okay, so it takes 8.5 minutes for the light to get from the sun to the Earth.
Okay.
8.5 minutes, and in that 8.5 minutes, that light traveled 93 million miles.
Okay.
So take that by
into a day,
and then multiply that times 365, and that's how far you get light travels in a year. Our closest star, Omega Centauri, is 4.2 light years away.
That's relatively close.
And that's the closest, and that's the closest one. Yeah, and that's like your next door neighbor.
We would never be able to get there
with
current technology.
Never. It'd take us 10,000, 20,000 years.
Wow.
Yeah.
That's where you go. There's just space is huge. It's hard to wrap your head around how big that is. And, I'm sitting here going, so if the sun went out, we wouldn't even know for almost 10 minutes.
Yeah. 9 minutes later, then everything would go dark.
Yeah.
We'd lose gravity at that point, and Earth would be flung out into outer reaches of space.
Over in many ways. Yeah.
Yes.
Yeah. Okay. So these are targets though that when we say amateur, what price point do we leave the amateur telescope realm and get more into? I know that's tough because you could buy it on Facebook Marketplace
I wouldn't really say there's a price point where you go from amateur to pro.
Is it focal length? Is it?
No, I would say, yeah, I guess once you get to a certain aperture, which would be your diameter, your size of your scope, once you get to a certain size, then it becomes more outside the normal realm, where it's a custom made type of a thing, where you don't see them too often, especially the type of scope.
So a car has an engine and it's got a transmission.
Yeah.
The telescope has the body, the length, the tube.
Yeah. And it's got its mount.
It's got the length, the focal length. It's got the size of the mirror.
Yeah, or the lens.
That's
the aperture.
That's the aperture. And then the third piece is
your F ratio.
F ratio.
F ratio is pretty much your focal length divided by your
So it's the two together.
But they all have different. It's all for different things because lower F ratio is better for deep space objects, whereas a higher F ratio, like an F10, you're going to get amazing clarity for like the moon and the planets. You're going to get super details.
Yep.
May not get good magnification, but you're going to get good crisp detail. The crispness of it's going to be off the charts.
And that may not be what you want when you're looking into the heavens.
Yes.
Right. Okay.
Yeah. The type of telescope that you use is all dependent on what you're using it for.
Yeah.
Are you looking at for the moon? Are you looking at planets? Are you looking at deep space stuff? Are you going to be doing more photography as opposed to, visual, astronomy? So it's all dependent.
So would you say though, it's fair to tell someone who maybe has a telescope and hasn't found satisfaction in using it, maybe they're just not using it for the right target.
Yes,
And
the
so
right
to
tool.
consider
Yes.
that, right? So, because a lot of people that get telescopes probably receive them as gifts.
Yeah, it may not be the right scope for what they're trying to use
Yeah.
it for.
You're staring at the moon with something that would give you an incredible view of something that's a little bit further away. Or
Or vice versa.
Or vice versa. Yeah, you're looking at something that just, you're underpowered.
Yes.
Got it. Microscopes would be the same way, where a kid gets a hobbyist microscope and it's like there's limitations to it. You can only go so far with that. And telescopes would be, I would imagine,
Equal.
the same.
Yeah.
No different.
Absolutely.
So we've got the telescope that I've been describing, which is on a mount, a tripod. if you
Yeah,
will,
that's
right?
it's an equilateral mount.
Equilateral mount, and you've got two knobs on it. You've got one knob that will tilt the tube. And if I'm using the wrong terminology, just correct me. But
No,
the
tube is fine.
it goes
for
like this, up and down. And I can get it to go almost vertical, almost 100%, straight up and down. And then I have another knob that will take it this way through the sky, left and right. And you don't really need to manipulate it by hand.
No.
And I don't think you're supposed to, or you're supposed to really use it.
Unless you're changing to a different object.
Right.
In which case, then you got to kind of reset it back up for that, for that next object.
Yeah.
But once you have an equilateral mount, telescope centered on a piece, if you have it set up right, you just have to turn the two little knobs and it'll stay within your view the entire time.
Because as that target's moving, and it will move, everything moves, and then you can just simply slowly dial, and it will move the telescope in the frame.
Yeah, it's
really
following the
special.
Earth's rotation pretty much.
Yeah, exactly. Because you've set it and you've told it what your altitude was, right?
Yeah.
Isn't that correct? So it knows pretty much how to follow a target in the sky. I don't have it, but they even sell computers that will guide it.
Yeah,
right. You have that as well. A go-to mount.
Yes.
Yeah. And those are cool too. So if you haven't, and again, this is like the progression of the illness of, telescope.
It's a rabbit hole.
Yeah,
Once
you
you
basically,
go down,
once you
don't
go
come out
down,
of.
you
Yeah.
always want more. You want a better magnification,
Bigger aperture.
bigger aperture. So you have mine, which I like. It's easy to transport. It's fairly, once you've set it, if you're not moving geographically, there's not really any need to do fine tuning. I know you've done some, what is the term for
Collimation. Yeah, for certain collimation. Yeah. Certain telescopes need, the mirrors need to be aligned. Like now your type of telescope, it needs to be done once in a while, but mainly when it's moved around, jostled around like
throw
that.
it in the car.
But yeah, but if you just keep it on the tripod and stuff, and once it's aligned and once it's the mirrors aligned and stuff like that, you don't really have to mess with it too often.
Yeah. Usually when I see him, I ask him, hey, could you use the laser on it and do that just to check it? But yeah, I think it's been done 3 times since I've had it.
And your traditional telescopes, your refractors, they don't even need collimation because they don't use mirrors. It's all based on the lens, and that lens is set in the tube where it's at, and it can't move.
It's not moving. Yeah. Now that's where I'm at, but now you've got several other types. My favorite one that I threatened to buy is the Dobsonian. Now, the Dobsonian mount, I'll show you a picture of one right here. You have an 8, 10, and 12-inch aperture.
Yes.
So that is, when you think about the tube of his telescope is now either 8 inches, 10 inches, or 12 inches. So a dinner plate. Big view, right? And as you'll see, it sits on a mount that rocks this way. It doesn't go it doesn't move this way. It'll, actually it's almost on like a Lazy Susan,
it's on a Lazy
right?
Susan, yes.
So you can move it 360 and
rock it
and
back
rock it
up and down. Yeah.
So this is like a really significant telescope that you feel you're hoisting it. I mean, it's a really smooth moving but heavy telescope. Yeah. And once you get set on it, because it has such a large aperture, your picture that you're looking at, or what is it that I'm trying to say? Like the view. You can see a lot. So if it moves, as it's moving, you don't constantly have to adjust it where you have a large point of view frame.
Yeah. Well, it's also dependent on the on your eyepiece that you do. Your higher magnification, you're going to have a lower eye relief, and you're going to have a lower field of view. So it's going to move out of the field of view a lot quicker. And
so every scope is going to have that, guys. And you can interchange the eyepieces generally, right?
Oh, yeah.
So you're going to need, regardless of if you have a Newtonian, a Dobsonian,
reflector, Smith Cassegrain, no matter what kind you have, you're going to need different eyepieces.
Yep.
At least 2. At least 2. So that way you have a a wider view and maybe a closer up.
Yeah.
view
And
of
I
things.
would say get a set where you have 10, and because you'll be amazed at the difference between, just a couple millimeters in the lens size. The Dobsonian is one that it takes up a little bit more space, a little bit more challenging to move, though. You move them
a little bit heavier than bulky, heavier, but price wise and aperture wise, you get the best bang for your buck for it. And plus, I also think that it's the most kid friendly version.
That's what
of it
I
as
was
well.
just thinking, man, because mine, a kid could knock over in a
You
moment.
bump into the tripod and you got to recenter it.
Whole thing's gone.
Yeah, you got to recenter with your object, with your polar alignment.
Yep.
With the Dobsonian, you bump into it. Okay, fine. You just rock it right back to where you want to
Yeah.
look at, and it's right there.
Yeah, it's a really special kid friendly, because I've seen you'll put a step stool
Yeah.
up to it so that the kid can get up there, and that is a really, really special way to see.
Because it's not your
I love
traditional
that one. That's my
telescope. It's not
favorite,
your
yeah.
traditional telescope where you're looking at the bottom of it.
Right.
An eyepiece. You're looking at
Yeah.
an eyepiece that comes up near the top out of the side of it.
Way
'Cause it's
better on your
because it's
back.
reflecting. Yes.
Yeah, because I'm tall and I've got a bad back, and when I'm looking at the telescope, if I'm hunched down trying to shoot into the eyepiece, it gets a little frustrating at times.
And that can be
Yeah.
another hobby killer
Yeah.
for certain people
Yeah.
too.
Start going. And the other thing I give Mike a hell of a lot of credit for is that you don't get to decide when something is in your view. So I know Mike will say like, "Hey, 2:35 a.m. There's going to be a great shot outside. Go out in your backyard." And I'm asleep. And if you want to see that shot, like he's talking about, there are times when the
That's the only
clouds will
time you can
part.
see it.
That is when you have the best window to do it. And so that brings me though to the Mac Daddy of telescopes. I know everyone has their own, but the Sea Star that you have is the third one that I want to mention. And this is one that I'd like for you to take a moment and kind of explain how this works and how you use it, because most people think of a telescope as, okay, mosquitoes are biting,
Yeah.
kids are tired, we want to go inside, it's cold out tonight.
Cold. A whole,
Whatever it
whole
might
bunch
be.
of conditions can be.
Tell me about the Sea Star and how someone could take that and what they could set it up in the evening, and then what they could end up with in the morning.
Okay, well, the Sea Star is not your traditional telescope where you set it up and you're looking through an eyepiece and stuff like that. It's a totally all electronic telescope that you run off an app, either on a tablet or on your smartphone, or even potentially a PC. But it's all done remotely, so you don't even have to be outside to run this thing. You can be, set it up outside, get it leveled, give it, do what you need to do to get it set up, and then you can go inside and relax. They even have updates now where you can set what objects you want to look at and pretty much set it and forget it, and have an itinerary for the entire night of what you want to look at, and it'll do its own thing by itself.
Yep.
Film it for an hour, go to your next target for an hour, and do that. And the great thing about this telescope is that they're always updating the firmware for it, and that's always adding new features to it without the having to buy additional equipment.
Yeah.
So they're adding built-in
that.
filters to it
Yeah.
that you don't have to go out and buy. They're adding 4K and better stacking programs to it, where you don't have to go out and buy those additional stacking programs, which you do. If you're doing your own processing and your own photography, you got to do that. You got to buy programs to stack to process your photos.
So you've got a telescope that is set up that has
It's a big
automation.
rabbit hole. It's a big rabbit
It's a rabbit hole, but I want people to understand what it does, because it will lock on to a target in the sky. So it knows, it's got a clock on it, so it knows what time it is. It knows where the target is related to you. And I want to talk about stacking images, because I didn't know what this was when I first met you, but it take a picture.
Most people say, okay,
Take tons of pictures,
You take
right?
one picture and you got that picture there.
There it is.
Now, a stack picture is pretty much you take the same picture, you take it, say, 100 times, like that.
Yeah. Is it
And-
that quick? I mean, is it taking it that fast?
No, the longer the exposure that you have, the more light it gathers.
Okay.
Your phone or your camera or whatever, your sensor gathers more light.
Okay.
More light means it's going to be brighter. You're going to see more
Right.
things are going to pop up.
Right.
Now, and most people, you can do that with your cell phone. You can set it for 30 seconds and take a picture, and
Yeah.
you might get a little picture of the Milky Way even pop up or something, But the more longer it is, the more stuff will pop up. Now, cameras and stuff have limitations because of, Earth's rotation. So you're going to get trailing. You're going to get stars look like they're going to start moving and stuff.
Yeah.
Things aren't going to be points. They're going to be streaks and stuff.
Right.
So the only way to get around that is to take shorter exposure pictures, 30 seconds, a minute or whatever, and then combine all those pictures together to make one super picture that has all the data together.
Yeah. And
so when you see a NASA picture and stuff like that of some galaxy and stuff, that's a stacked photo. That's a processed photo that involves hours and hours worth of data.
This again is how hobbyists get discouraged.
Yes.
Mike, so a lot of people will look at telescopes online and they may be able to go to Amazon.com and buy a new one. And that's great. We love it for them if they can. It'll come with instructions, maybe tutorial videos, a cute QR code that you could use. But there's other people like myself that are constantly looking for a value. And so they may look at Facebook Marketplace. They may look at OfferUp. They may look on Craigslist. Reddit also has several subreddits that are exchanging gear, selling gear. That said, there's dangers that come with buying a used telescope.
Absolutely.
And I'd like to just talk about maybe 2 or 3 things that the average person going to look at a telescope for sale that's not new should look out for. Number 1 would be refraction. Tell me a little bit about that.
You want to make sure that the mirrors and lenses are properly working, because that's going to be your biggest cost of it. So if that's not working properly, you might as well just get a new scope.
So but how would I know that? Is that an age of the scope thing, or is that something that would be the way that it was treated by the owner? Mainly
treated, how it's treated and stuff. If it's covered up and stuff, that helps keep damage minimized and stuff. Because the mirrors of some telescopes, they have a silver oxide coating on it, and after time that can degrade, and it can degrade your quality of the images that you see.
You still see bright objects in this mirror, but it's a dull mirror. It would be like if we looked in a piece of shiny metal versus a glass mirror.
Yeah, or something that was dirty as compared to, clean.
Yeah. And so that would be something that not necessarily the age of the scope, but how it was kept.
Yeah, how it was stored and stuff. If it was stored in a humid area and stuff like that, because obviously it's just like any other piece of equipment. You want low humidity. You want better conditions for it to be in, covered, no dust, stuff like that.
Dirt and dust. Yeah. All of your environmental factors that would impact an antique guitar or something like that. Yeah, that makes total sense. Looking at that, then the second piece would be
your base, your mount. You want a stable mount, something that's not too light for the telescope that it's being used for. So you want something that's stable, that's not going to be shaky, because you want a nice steady view when you're looking at things. You don't want things going out of your view or distortion or anything like that, because things are shaking.
And you have tabletop mounts, and you have equatorial. Is that the term that you would use for mine?
That's your
more of a tripod, a larger.
You got tabletops, you got Dobsonian mounts, you got Alt-Z mounts, you got all different
go-to mounts like we talked about.
Go-to mounts with electronic mounts where they'll just take you to the object by itself.
Yeah,
those are fun.
Yeah, those are very fun. And so if I'm going, though, as an individual to buy one, because, telescopes are one of those hobbies, like guitars, like motorcycles, for example, that when the times get tough, these are the items that people tend to sell. And it's a heartbreaker every time they do it. But I could go anytime, day or night, then, and look at this, and I could use a distant street light to calibrate, to make sure that the mirror was right on it, to make sure that the mount was accurate. I could also ask the owner if they have pictures that they've taken with it.
With it, yes.
Assuming that they're using it for photo, like you said earlier. They may not have used it for that. What are some other items that I should be looking at, though, to make sure I don't get burned?
Well, first of all, I would say really important is you want to make sure it's the type of scope of what you're looking for, what you're looking to do.
Okay.
Because certain scopes have different pros and different cons. They're made for different things, or they excel at different things. I mean, you're going to be able to see something with all telescopes, but they're going to excel at certain qualities as opposed to others. Certain scopes are made for astrophotography as opposed to more visually. Others are more kid oriented and stuff like the Dobsonians, as
Yeah.
opposed to the ones on the equilateral mounts.
Yeah.
That can get bumped and you got to reset it. And so you want to make sure it's something that, how tall you are makes a difference on what type of mount that you get,
Yeah.
and the height of the scope. So you're not bending over. You want something that's going to be comfortable for you,
Mhm.
something that you can be out there for hours and not end up with a sore back if need be.
Happens all the time.
Yeah.
Yeah. I prefer the height of the Dobsonian mount because I'm 6'2", and it is right at just the comfortable standing height. And then a kid could jump on a little step stool and be right
ladder,
where they need to be. I also like the Dobsonian, Mike, because of its resistance to being moved, interference. It's a little more
Bumping and stuff
sturdy.
like
Yeah,
that,
it's a
yeah.
little more
More forgiving when it
kid-friendly,
comes.
forgiving.
Yeah.
Yeah, for sure. Okay. And are there any other items, though, that you could think of if I was going to buy one online that I may want to ask the owner to make sure that I'm covered? Am I likely to get burned if I buy a used telescope?
Not likely, but I mean, if you don't know exactly what to look for, you might end up something that already has existing damage or something like that.
I've run across less of that and more of, I know what I've got.
Yeah.
Like they want retail top dollar for the scope when you could buy it brand new.
Yeah. You don't want to pay retail, for a used scope.
Yeah.
Because if you're doing that, you might as well just buy it new and get it with the warranties and everything else that comes with it. With the new ones.
I know, Mike, that we'll have people that will say, "Well, I am on TikTok and I want to share my view on a TikTok live." Is there one scope that would be better than another to do that with? Would the C-Star be the one to use that for, to stream?
C-Star is not mainly a streaming one. But I mean, I suppose you could. I suppose you can use any telescope for it. For
just
streaming,
using the
so.
mount that we discussed and then having your phone on it.
Yeah.
I can tell you that just my experience, and I'm not a tech master, you will find it frustrating to do, especially if you're tracking a smaller target that's moving across the sky. Now, if you had the right equipment and you were just looking at the moon or the sun and it's not really going to move that much, I think it would be okay. But if you're trying to capture Jupiter and you're trying to really stream the moons, you're going to potentially get frustrated with that as it moves across and you're bumping your scope.
A lot of trial and error,
A lot of trial and error. Yeah. And sometimes the real answer is be in the moment, put the phone down, and just enjoy the view. For me, it has been that way. When I have tried to catch things on film, I've missed out on it both first and second doing that. So I always say, I don't know what the best scope is for that, but I do see people on TikTok Live that will stream a solar filter like you were talking about, or if it's a good shot of a crescent moon or something that they can get a real good shot and have good conversation going while it's on the screen. I just wondered what would be the best type to do that with.
I've done Facebook Live before with like the moon and some planets.
On the Dobsonian or
on the Dobsonian.
Yeah. And did you just use a mount like we were talking about?
Yeah, just a regular cell phone mount that connects to the eyepiece.
It does take some
adjustment and stuff to get it aligned right.
Absolutely. Before we wrap our episode, Mike, we've got to give the people what they want, which is 3i Atlas. We're talking about the third intergalactic object ever spotted by man and documented in history, spotted by Atlas. Give us some flavor for what you've heard so far.
Discovered July 1st. It's a comet, approximately 2 to 6 miles wide. Interesting thing about it, it's moving super, super fast. It's one of the fastest objects we've ever found. It going through space, 130,000 miles per hour. Like it's zooming. It's going 3 times faster than most objects normally do.
Yeah.
Another weird thing about this is that its chemical composition is a lot of carbon dioxide, which is not natural in comets. Mostly comets, they do have carbon dioxide, but not the amount that this one has. This one has 8 times the amount of a normal comet.
Dripping with it.
So that can mean a lot of different things. It can mean that its origin is from a different area than most comets are from. Or it could have traveled through environments that, with different conditions, different radiations, different elements involved.
I love that idea that we know a lot about what we know and we know nothing about what we don't know. And so when you think about 3i Atlas coming in, being flung at us from a region that we've never even explored.
Yeah.
We know nothing about the elements that are available there. We know nothing about carbon's relation to the atmosphere there. What we know is that it may have went through something that's causing that elemental signature.
Potentially,
Like you
yeah.
said, a supernova that it passed through that peppered it with
Gamma radiation
gamma
or
radiation.
something.
Yeah, man.
Or maybe it just went through some kind of gas cloud that was rich in certain elements like the carbon or
Yeah.
whatever. And,
It's shedding that as it's,
yeah.
it's flying through space.
Flying.
And then as it continues to navigate our space, it may show different hallmarks as well. It may continue to gas off. It may continue to show. I've saw nickel without iron, high CO2, very low H2O, and all of these things where we say, well, it just doesn't make sense. But again, this is not made in America. This
Nope.
is not something that was made here in our backyard. This is from a galactic standpoint. This is somewhere very, very far away where life can be completely different than it is here. Math could be different. Physics, the rules of science may not apply.
It's the first comet that we've discovered that's come outside of our own, interstellar area.
Yeah.
The other two interstellar objects that we have found prior were pretty much asteroids. They were rocky objects. They had chemical composition like most asteroids and stuff too. Nickel,
Made
iron,
sense. Yeah.
Stuff like that, stony material. This one here is, like I said, it's a comet. We know it's a comet, but its composition is totally different from any comet that we've experienced before.
Yeah. And that's what makes it a little bit different.
Yeah.
Our tools and our technology is better today than it's ever been. Our eyes reach further into space than they ever have before. And this is just part of our story.
Just adds questions to it.
A lot of questions.
Yeah.
And we'll know more. I think you shared with me earlier that Atlas currently got its sights set on Mars.
It's approaching Mars on 3rd of October. It'll be 18 million miles away, which seems like a lot, but in a cosmic scale, that's very close. That's like your next door neighbor.
Yeah. You're
That's
still using digits.
Yes.
Instead of saying, astronomical units or light years, we're talking 18 million miles. It's not that far. Mars is how many million miles from Earth?
I would say
I've quizzed you on this before.
about 100 million, approximately.
So when you think about that now, and I went to this earlier where I said, well, if you could see Mars, then you should be able to see that. But we're talking 6 miles.
Yeah. As opposed to thousands of miles.
This is
like
a
Mars.
speck of sand. It's a grain of sand in the universe here, but it's moving fast. It's moving at a speed that we're not sure why. It's moving in directions that are, from a statistical standpoint, unbelievable. This is more to come. And we know that once it goes past Mars, it will then approach Jupiter. And after that, will be behind the sun. Is that right?
No, it'll be behind the sun after Mars. And then next year, I think early April, it's going to make its closest approach to Jupiter.
And then where ultimately is this going to go?
Just out our solar system and
into the next.
And that's
what's crazy too. There's another solar system here, and there's us, but there's something over there too. It's a wide world. It doesn't all just come from one direction.
It could be a million years before it even hits that next solar system, or even
we don't know how long
or before it even encounters anything.
Yeah,
I mean, it can just be going through the vastness of space and may not even encounter anything else ever again in its lifetime potentially.
Yeah.
You never know.
When you think about it, though, they could say at the speed that it's going on the trajectory, they would know when it would exit. But we don't really know where the exit is. We just know.
We don't know the official boundary of what our solar system
There's no
is.
line. There's no gate. There's no fence. It's just that we know that it's a long way away. And, we sent Voyager out 50 years ago, roughly.
Yeah.
Is that right? And it has traveled a long way from home and continues to report back. But again, in the grand scheme of things, it's not that far away. It hasn't gotten that far. It will take, how long did you say for it to get to the nearest star?
10,000 years, 20,000 years. Like, let's put this in perspective. Voyager has been in space for approaching 50 years now, since the late 70s. One astronomical unit is 93 million miles. This is from the sun to the Earth.
Right.
Voyager's only gone 40 astronomical units so far in 50 years.
Long way to go. So
it hasn't even reached the boundary of our own solar system. Like it's right at the edge of it, but it hasn't gone into interstellar space yet.
Is it that's not crashed into something?
The distances are so far apart.
But I mean, even just a random.
There's
nothing out there, is there?
Nothing. Like even if you take like your asteroids in the asteroid belt in between Mars and Jupiter, they're spaced out tens of thousands of miles in between every asteroid.
So yeah, again, you start talking about how little we are and how big those things are. Yeah. And that we could navigate through an asteroid belt, I guess, because it may be.
Yeah, it's not like on Star Wars where they're diverting and you got the Falcon going past all the asteroids and they're weaving in and out.
Yeah.
No, they're not that close because if they were that close, the gravity
would pull them together.
Would pull them together, and they would affect the orbits of every asteroid if they were that close.
Yeah. I'm glad that you said that because we really know what we see on TV.
Yeah.
But it is true. You do see them like going through and jockeying through space. And Voyager is one of those things that it went dark for a long time and then started communicating with us again.
Yeah. Yeah, just recently too.
Yeah, we never know how long that communication will stay and when we'll lose it again. But the fact that with our technology then we were able to do that is a really special feat. And to think that there could be somewhere civilizations that are far beyond our, education, our discoveries in science and space, and that they could very much intentionally avoid us.
If they want to,
just to say
maybe we're not intelligent enough for them.
There's a reason I don't take hikes through the swamp. You know what I mean?
Or it can just even be even if they have the technology available, just the vast distance in between star systems and stars and galaxies.
Yeah, the kid saying, "Can we go see the Golden Gate Bridge?" And this alien saying, "Like that's 100 billion miles away."
The Milky Way galaxy, just our own galaxy, our own individual galaxy, is 100,000 light years across. So even if you're able to travel the speed of light, it's going to take you 100,000 years to get from one end of it to the other.
Oh,
so that tells you, even if you have the technology to move that fast, the distances in between.
Yeah.
Between humanity and whatever civilization might be out there, it's going to be too vast. They may not ever reach us. The civilization might die out before they reach us.
Before they could even make it.
Yeah.
Yeah. That's really wild to think.
I mean, there can be multitudes of civilizations out there, intelligent ones, but we'll never come across them because it's so far apart.
Yeah. Wow.
I mean, there can be tons of them, but I'm absolutely certain that there's life, microbial life, bacterial life in our own solar system. Some moon on Jupiter or Saturn, potentially even on Mars, buried deep within, might be a microbe or something.
Yeah.
But we already know that there was water ice on Mars. There's even proof that there's on the moon, in some of the craters at the poles, that there's frozen water ice.
Wow, that's a game changer.
Yeah,
because when you have water, you can have
potential life.
Chemical. Yeah, you can do all kinds of different.
Chemical things. You can create energy. Because when you break down water and you break it into oxygen and hydrogen molecules and atoms, it creates a large amount of energy. Believe it or not, actually, that's what we use to power all of our rockets and stuff. That's what we use for fuel. We have two tanks. One's got hydrogen and one's got oxygen in them. When they combine, it creates a huge amount of energy, and the byproduct of that is water.
Yeah, that's crazy.
That's what we're using to power our rockets to escape Earth, is water, pretty much.
Wow. Yeah.
But the energy involved in it is just amazing.
Yeah. It really blows my mind to think 100,000. I want to say that again. If you were traveling the speed of light, if you could get there, which the speed of light is, the light that leaves the sun takes just under 9 minutes, you said, to get here.
Yeah.
So that's how fast you would go. 93 million miles in 8 minutes. If you could do that, it would take you 100,000 years. So 1,000 great lifetimes
to get from one end
to get there
of the galaxy to the other end.
That's so hard for me to really even
understand. And that's just one galaxy.
Right.
Our closest galaxy to the Milky Way galaxy is the Andromeda galaxy. That's 2.5 million light years away. So even after traveling at the speed of light, it's going to take you 2.5 million years to get there.
Yeah.
Galaxy might not even be there by the time you arrive.
Yeah. And then, Mike, just real quick on that, the whole speed of light thing, looking into space, talk to me about how, I said if the sun were to go out,
It's like looking in a time machine.
Yeah, it's a time machine. Like,
time
talk to
machine.
me about that. How when you look at some of these supernovas and you look at some of these explosions in space, it's not a real time event because it
No,
took
you're,
so
you're
long.
seeing it what it used to look like.
So
Like
crazy.
you look up in the sky right now, you see the sun. You're not seeing the sun how it is right now. You're seeing where it was 8.5 minutes ago. Because in that 8.5 minutes ago, from the light to get from the sun to reach us, that sun's already moved a couple of degrees across the sky. It's in a different position.
Yeah.
We just can't see it yet, but it's there.
Yeah, that's crazy.
Yeah, it's crazy when you feel that. It's there, but it's not really there.
Yeah, it's a delay.
It's a
Just
delay.
like a TV signal, same thing.
So if you're looking at some object that's 60 million light years away, you're looking at that object how it appeared when the dinosaurs were living on the Earth.
That's wild.
And it would be the opposite if some other
That means in your
civilization-
lifetime, though, you'll never get to see what that star actually looks like.
No, you see what it looked like in the past,
Yeah.
but not what it's looking like in
Yeah.
the present.
Yeah.
Just like you hear about people are talking about Betelgeuse. It's going to explode,
Yeah.
supernova. It might have happened already.
Won't
The
even know.
light hasn't reached us yet.
Yeah.
And and it's almost reversal. If there's some intelligent civilization out there that has some kind of telescope or equipment that can see humanity, see Earth, say they're 1,000 light years away from us. They're not looking at Earth in the year 2025. They're looking at the Earth in
Caveman.
1025.
Oh.
1,000 years ago,
Yeah.
because it took 1,000
Yeah.
years from the light from Earth to
Yeah.
get to their civilization.
Yeah. And just like
So they're
just
looking
like
at
our
the dark
frustrations
ages.
with the moon, they wouldn't be seeing, oh, there's Mike hanging out in Estero, Florida.
Yeah.
They would just see
They would
the
see
planet.
they'd see the dark ages. They'd see
Yeah.
there wouldn't be any technology, civilization. I mean, there was civilization, but
Nothing.
nothing right now. They
Yeah.
wouldn't be seeing cars or automobiles or anything.
Yeah. Yeah. That's wild, man.
They'd be seeing us in the past, just like we're seeing them in the past.
Yeah. Yeah. That's just a mind blowing.
But it's crazy that you can see into the past, but you can't see into the future
Yeah.
like that. So it's a one-way street.
It's a one-way street. And 418 years ago, when they got that first telescope out, they were seeing a different picture than we see today.
Yes.
Although,
absolutely.
because of how long change takes, it really probably does look pretty much the same. If you
Yeah.
think of 300, 400 years in the scale of, the universe,
that's
it's
nothing,
man. It's a
nothing.
moment. It's a moment in
Yeah, if you took all of the universe's existence and you put it on a 24-hour clock,
Uh-huh.
humans arrived at 23:59 and 48 seconds. So humanity only existed for the 12 seconds out of the 24 hours
Wow.
time period.
Let that blow your mind. Because if you've ever seen movies like, 10,000 BC or where they talk about, cavemen and all of this, keep going back. Go
We're
way back.
dropping
Go
the bucket.
way back. And I wondered about that. I was thinking about that before we got together today. I go, considering cavemen, running from tigers and lions all day, like just trying to live and survive, at what point did they stop on their way back to their cave and look up? And think like, wow, I wonder where we came from. I wonder what's out there. Because we didn't have the luxury, even in the 1600s, you're really just worried about making survival.
Yeah.
1700s, 1800s. Probably wasn't until the 1900s really that people were getting more into.
You got more of the luxury of having expendable time and stuff like that.
Yeah, man. Absolutely. And we've come a long way, but we've got a long way to go. And I don't know that we'll ever have a view that will satisfy man's curiosity, because we love to travel. We love to know what's around us. But I think sometimes it's okay to have a little of that curiosity there and maybe not know, and give us an opportunity to dream and to,
absolutely.
to wonder.
It's what spurs exploration.
Like I said,
Not knowing what's out there.
we get to trick or
undiscovered.
treat and they go, dude, it was just a rock, then that would be good, because we'll know that we're safe and we
Yeah.
can look for the next rock. But there will be something there where we know we'll say, oh. So maybe if we're not able to see it because of the position behind the sun, maybe it's good for our spirit of exploration and to keep us, looking for the next rock. We've had Mike Derengowski here in the studio with us today. Mike, before you go, my underwriter, Westcore, Mario, asked me to give this to you. He was a part of the event that we did in January, and he bought this for you. It is a cosmic orb, and he wanted to give it to you in appreciation of your partnership with us and for everything that you do for the community. I hope that you'll enjoy it. It's a night light that actually projects an image of the globe up on the ceiling. I have one at home as well. I hope that you'll enjoy that token gift.
Absolutely.
Really appreciate you coming onto the show. Mike is a friend of mine. I'll put his contact information in the show notes if you're interested in asking him any questions, picking his brain, or attending a future event. Mike, how often are you planning on doing the events at the park in this fall?
Well, hopefully starting October when weather gets better, every other Saturday or so at the park in the evening times.
Saturdays, 7-ish, sunset in the
around
fall.
sunset.
Yeah.
If the moon's out and available during the daylight hours, I even get out there a little bit earlier, and because the moon's one of the things that you can check out at any time of the day.
Yep. And Lehigh Acres has a Facebook group that you may want to join. Mike is active in that as well, and he usually posts his viewings, and I try to post them as well. So if you'd like to connect that way, that would be great. Yeah, Veterans Park in Lehigh Acres. It's a great viewing area. Usually when we've been out there, there's always, 10 to 15 people that stop by, and you're always welcome out there as a member of the community. Mike, thank you for stopping in.
Absolutely.
My name is Adam, and I do title. If you're buying, selling, building, refinancing, or doing a deal in Florida, tag me in. I'm local, I'm licensed, and I give service that's out of this world. Have a great day. Thanks again, Mike. That's a wrap on Title Adam in the House. Subscribe, share, and tag in Title Adam when it's time to close. You want to be a guest? Book your spot. The link's in the show notes.